In this lesson, we're going to consider one more problem where we're using the sampling distribution. Let's go ahead and read the problem. The length of time taken on the SATs follows a normal distribution with a mean of 2.5 hours and a standard deviation of 0.25 hours. Samples of size 60 are randomly selected from the population. Let me make a remark here. In part A, you're finding the probability of a sample mean being between 2 hours and 3 hours. In part B, you're finding the 95th percentile of a sample mean. Here, we know that we need to use the sampling distribution. We need to use the X-bar distribution. Before we do that, let's go ahead and summarize the given information. What is the X distribution here? X-bar is a normal distribution of the time taken on the SAT by one student, by one individual. We're given the mean for this distribution. Mu of X is equal to 2.5. We're also given the standard deviation. Sigma of X is equal to 0.25. Here we're going to consider samples of 60 students. We have n equal to 60 here. To be able to apply the central limit theorem to say that X bar follows a normal distribution, we need X to follow a normal distribution, or we need n to be greater than 30. Notice here, both conditions are met. X is a normal distribution and n is equal to 60, which is greater than 30. So I'm going to write that here. Since X is a normal distribution and X is equal to 30, by the central limit theorem, we can conclude that X bar follows a normal distribution. So let's go ahead and write this using the notation X bar follows a normal distribution. What is the mean of X bar? The mean of X bar is the mean of X, which is 2.5. The standard deviation of X bar is going to be the standard deviation of X, which is 0.25, divided by the square root of n. N here is 60. So we're dividing by the square root of 60. Now, if I take 0.25 divided by the square root of 60, we don't get a nice number. We don't get a whole number. We don't get a terminating decimal. So I'm just going to keep the standard deviation of X bar as 0.25 divided by the square root of 60. Okay? Remember, in statistics, we don't want to round. If I go ahead and round here, and then I use the value that is rounded to compute something else, my final answer is going to be wrong. That is why I'm not going to enter that on a calculator. Okay? I'm just going to keep it as it is. Okay? Now, if you're finding the probability that a sample mean is between 2 and 3 hours, that is P of X bar being between 2 and 3. If we're wanting to find this probability, you have a function on your calculator, on Google Sheets or Excel, that can help you find this probability. Okay. I'm going to have you do this on your own, but let me give you a hint. If you're using a calculator, you're going to use normal CDF. If you're using Excel, you're going to require to do a few more steps, but here is the distribution that you need to use. You need to use norm, the DIST. You're considering the normal distribution of X bar. You know that the center is at 2.5. Here, you're trying to find the probability of X bar being between 2 and 3. Okay. That is the area under the X bar distribution between X bar equal to 2 and X bar equal to 3. Okay. That is the area you're finding. That is the probability of a sample mean being between 2 and 3 hours. So I'm going to have you do that on your own. Now, what if you're wanting to find the 95th percentile for a sample mean? Let's go ahead and visualize what we're trying to do here. Because we're talking about a sample mean, we're going to use the X bar distribution. Here, you're being asked to find the X bar value. What is this X bar? Such that 95% of all X bars are below this X bar. In other words, what is X bar such that 0.95 of the area is below this X bar? On your calculator, on Google Sheets or Excel, you have the option to use IMB norm. The IMB norm function will help you find the X bar corresponding to the 95th percentile. I'm going to let you do that on your own. We are at the end of the lesson. In this lesson, you were introduced to the sampling distribution. the distribution composed of sample means. You were introduced to the central limit theorem. Now you know the conditions that need to be met for us to be able to apply the central limit theorem. Once we establish using the central limit theorem that the sampling distribution, X bar, follows a normal distribution, then we can go ahead and find probabilities, and we can go ahead and find percentiles for sample means.